Hi, welcome to Nomis Academy. In this video, we are going to learn how to find the derivative of a function from the first principle. Alright, let's pick the first example. But before we do that, I would like to explain this. Whenever you are given a function to find the derivative, what you do is you consider the limiting value. In that process, the process is what we call differentiation from first principle. Let's pick the first example. Example 1. Find the derivative of y equal to x raised to the power of 3 from the first principle. Alright, solution. Remember what I said? When you are given a function to find the derivative, you need to consider the limiting value. That process is what we call differentiation from the first principle. Alright, let's proceed. Now we have y equal to x raised to the power of 3. Any increment in x will definitely lead to an increment in y. Let me write it. Increments in x will lead to an increment in y. So we have y plus delta y. Delta y is the increment of y, and then we have x plus delta x raised to the power of 3. Delta x is the increment of x. So the next thing we need to do, we need to expand x plus delta x. This is the cubic form. So we have, to do the expansion, we have x raised to the power of 3. We are using the idea of binomial expansion, okay, using Pascal triangle. Since we have 3 as the power, the coefficient will be 1, 3, 3, 1. And then as x is decreasing, then delta x is, the power of delta x is increasing. So that will be x cubed. The coefficient is 1, x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed. So we use binomial expansion to expand this. I repeat again, use the coefficient according to Pascal triangle. The coefficient in this case is 1, 3, 3, 1. Alright, the power of x is decreasing and the power of delta x increases at this point. You can see delta x raised to the power of 1, delta x raised to the power of 2, delta x raised to the power of 3. Alright, so we continue in the solution. So the next thing we do, we are going to subtract y from both sides. So that will be delta y equal to x squared or x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed minus, since you are subtracting y, the value of y is x cubed, so we write x cubed. So here we have x cubed minus x cubed, which is 0. So we have delta y equal to 3x squared delta x plus 3x delta x squared plus delta x cubed. Now we divide through by delta x. So divide through by delta x. So that will be delta y divided by delta x equal to 3x. Okay, this is 3x squared delta x divided by delta x plus 3x delta x squared divided by delta x plus delta x cubed divided by delta x. Alright, so we go further. Delta y over delta x is equal to, when you cancel out here, you have 3x squared plus delta x squared divided by delta x, you get 3x delta x. So that is 3x delta x. And in this case, delta x cubed divided by delta x will give us delta x squared. So you write plus delta x squared. Now at this point, we are going to take the limiting value of x, and that will be limit as delta x tends to 0, so dy dx equal to, we take the same limit in this case, delta x tends to 0, so we have 3x squared plus 3x delta x plus delta x raised to the power of 2. So remember, when you take the limiting value of delta y delta x, you get dy dx. That is taking the slope of the secant, or taking the limits of the secant, and then it becomes the slope of the tangent, which is dy dx. That's the slope of the curve. And then wherever you see delta x, you slot in 0, and we have 3x squared plus 3x raised to the power of, okay, multiplied by 0 plus delta x squared, which is what? 0. So put 0 raised to the power of 2. So finally our answer is 3x squared. Anything multiplied by 0 is 0. So this is the solution to the problem. One more example. Example 2. Given that y is equal to 1 over x, find the derivative. The derivative of y equal to 1 over x. Quickly, increment in x will also lead to increment in y. So we have y plus delta y equal to 1 all over x plus delta x. Alright, we move y to the other side, and that becomes delta y equal to 1 all over x plus delta x minus y. And what is y? Y is 1 over x. Y is 1 over x. So the next thing we do is to divide through by delta x. Divide through by delta x. So that will be delta y over delta x equal to, we have 1 all over x plus delta x minus 1 all over x. Then we are dividing, so we can also write it this way, multiply by 1 all over delta x. We are dividing through by delta x. So let's move to the other side of the board. Alright, now we need to simplify what we have in the bracket. So we have delta y over delta x equal to, the LCM there is x into x plus delta x. That is, the LCM of x plus delta x and x is x into x plus delta x. So this divided by what we have here will definitely give us x minus x into x plus delta x divided by x is x plus delta x. So multiply by 1, we get x plus delta x. Okay, remember we still have something outside, which is multiplied by 1 over delta x. Alright, let's simplify this. Delta y all over delta x is equal to x minus x is 0, so we have minus times delta x is minus delta x all over x into x plus delta x multiplied by 1 all over delta x. So we can see that delta x can cancel this. And then delta y all over delta x is equal to minus 1 all over x into x plus delta x. So at this point, we are going to take the limiting value, which is limit as delta x tends to 0. dy over dx is equal to minus 1 all over x into x plus 0 as we are taking the limit. So this becomes dy all over dx equal to minus 1 all over x times x is x squared. So we can also have our answer as minus x minus x raised to the power of minus 2 in index form. Either this or this. So this is the derivative of the function y equal to 1 over x. Take this as your assignment and share your answer in the comment section. Alright, you've solved this and share your answer in the comment section. Thank you for watching. See you next time.